Right now, deep beneath the surface of the Pacific Ocean, something is building that scientists have never seen in their lifetimes. It is not a storm. It is not a hurricane. It is a slow, invisible surge of heat so massive that it is already rewriting the rules of global weather, and it is coming for every single one of us. The European Center for Medium-Range Weather Forecasts, one of the most respected climate modeling organizations on the planet, has now placed the probability of a super El Niño forming by November 2026 at 100%. Not likely. Not probable. 100%. That number is extraordinary. That number should stop you in your tracks. Because in the entire history of modern climate science, we have never used that word with this kind of confidence about an event this powerful. And yet, here we are. Let's talk about what El Niño actually is. Because most people hear the name and think it is just a weather pattern, something that brings a few extra rainy days and then disappears. That is not what this is. El Niño is a fundamental shift in how the entire atmosphere of this planet behaves. It begins in the tropical Pacific Ocean, where under normal conditions, trade winds blow warm surface water westward toward Asia and Australia. When those winds weaken or reverse, that enormous pool of warm water sloshes back eastward, spreading heat across the central and eastern Pacific on a scale that defies imagination. That heat does not stay in the ocean. It transfers into the atmosphere, and when it does, it physically displaces the jet streams of both hemispheres, rerouting rainfall, triggering droughts, igniting wildfires, and causing floods in places that have never flooded before. A regular El Niño does all of that. A super El Niño, defined by sea surface temperatures in the central Pacific rising more than 2 degrees Celsius above the long-term average, is a different category of event entirely. Only 3 have been formally recorded in the modern era, in 1982 to 1983, and in 1997 to 1998, and in 2015 to 2016. Each one caused catastrophic disruption across multiple continents. The 1997 to 1998 event alone caused an estimated $32 to $96 billion in global economic losses. These are not background weather fluctuations. These are civilization-level disruptions. And what is forming right now is shaping up to be not just another super El Niño, but the most powerful one since records began, potentially rivaling an event from 1877 that triggered the deadliest climate-driven famine in recorded human history. To understand the scale of what that means, you need to understand what happened in 1877. That year, a super El Niño of extraordinary intensity collapsed monsoon rains across India, China, Brazil, and sub-Saharan Africa simultaneously. Grain harvests failed across 4 continents at the same time. The resulting sequence of famines, which historians now call the global famine of 1876 to 1878, killed more than 50 million people. That was 3% of the entire world population at the time. Entire regions were emptied. Communities that had existed for centuries were simply wiped out. And scientists examining current data are now saying that the subsurface heat pulse building the Pacific right now is tracking at or above the equivalent development stage of that 1877 event. Paul Roundy, a professor of atmospheric and environmental sciences at the State University of New York at Albany, stated publicly in early May 2026 that confidence is clearly shifting higher on potentially the biggest El Niño event since the 1870s. That is not a fringe scientist making an extreme claim. That is one of the leading ENSO researchers in the world, speaking carefully and deliberately and using language that would have been considered reckless even 12 months ago. The scientific community is converging on a conclusion that was unthinkable just 1 year ago. Here is why the numbers are so alarming. NOAA, the National Oceanic and Atmospheric Administration in the United States, now gives an 82% chance of El Niño conditions emerging in May to July 2026, and a 96% chance of those conditions persisting through December 2026 to February 2027. The ECMWF has moved its ensemble model to show peak temperature anomalies in the Niño 3.4 monitoring region reaching 3 degrees Celsius, and local anomalies potentially exceeding 4 degrees. To put that in context, a super El Niño threshold is 2 degrees. We are talking about an event that may hit 50% above that threshold. NOAA estimates there is now a 65% chance the upcoming event will be classified as strong or very strong starting in October, potentially placing it among the strongest in the entire historical record. The mechanism driving this is a Kelvin wave, a massive pulse of anomalously warm water being pushed below the ocean surface by bursts of westerly wind, traveling eastward like a conveyor belt from the warm waters near Indonesia toward the coast of South America. Daniel Swain, a climate scientist at the California Institute for Water Resources, described the volume and intensity of the subsurface warm water anomalies as being about as large as anything ever seen in the historical record. He said plainly, one of the key building blocks to make it fully materialize is in fact occurring. The warm water to the east is already approximately half a degree warmer than it was at the equivalent development stage of the 1997 event, which was itself considered the strongest El Niño of the 20th century. What makes the 2026 event fundamentally different from every previous Super El Niño is not just its raw intensity. It is the world in which it is developing. Global average surface temperature is already running approximately 1.2 degrees Celsius above the pre-industrial baseline. The 3 years from 2023 to 2025 averaged more than 1.5 degrees above pre-industrial levels. Every previous El Niño in the instrument record was measured against a cooler ocean baseline. This one is being launched from a starting point that has no historical precedent. Professor Bill McGuire, Emeritus Professor of Geophysical and Climate Hazards at University College London, assessed in May 2026 that this Super El Niño is likely to push the rise in global average temperature above the pre-industrial baseline once again, with a realistic probability that both 2026 and 2027 breach the 1.5 degree threshold specified in the Paris Agreement as the upper boundary of manageable warming. That is not a technicality. That 1.5 degree threshold carries specific, documented consequences. Exceeding it at a sustained global mean triggers additional permafrost thaw across Siberia, northern Canada, and Alaska, releasing methane, a greenhouse gas approximately 80 times more potent than carbon dioxide over a 20-year period. That feedback loop, once triggered, does not reverse on human timescales. The climate community has spent a decade fighting to prevent that line from being crossed. A Super El Niño building on top of an already overheated planet may push us across it, whether we are ready or not. Now, let us talk about what this means for the United Kingdom specifically, because that is where a significant part of the public conversation has been focused, and rightfully so. The UK's relationship with El Niño is complicated. Unlike tropical regions that experience direct hits of drought or flood, the UK sits at the end of a long atmospheric chain. El Niño shifts the North Atlantic jet stream and alters pressure systems over the Atlantic, and it is through those secondary mechanisms that British weather is affected. Previous summers during developing El Niño events, in 1997, in 2015, and in 2023, delivered mixed results, though all three featured notable warm spells. But those were not Super El Niño events at this level of intensity, and they were not developing against a background of this much baseline warming. The Met Office, the UK's National Meteorological Service, confirmed in April 2026 that sea surface temperatures across a key region of the Central Pacific have been rising steadily in recent months, crossing thresholds that are used internationally to identify El Niño conditions. Graham Madge, senior climate science communicator at the Met Office, stated that a Super El Niño is not a term they formally subscribe to, but acknowledged that this is likely to be a significant event, potentially comparable to the notable El Niño of 1998, which coincided with what was, at the time, the warmest year ever recorded globally. The Met Office also confirmed that when model projections cluster as tightly together as they currently do, it increases confidence that the overall direction of change is robust. Multiple models are pointing in the same direction. That is a significant statement. Current forecasts from ECMWF and NOAA indicate an 80% probability of a strong event forming by late 2026, with the likelihood of extreme Super El Niño conditions standing between 20 and 25%. For the UK, the current seasonal output from numerical weather prediction models suggests overall warmer than average conditions across Europe this summer, with drier conditions in the north of Europe and average to wetter conditions in the south. That points toward a hotter, drier summer for Britain and Ireland than the historical average, with the caveat that El Niño's atmospheric lag means its most direct temperature impacts may not fully materialize until 2027. But the groundwork is being laid right now, in real time, and the fingerprints of a shifting jet stream are already visible in the data. For the rest of Europe, the picture is more direct and more alarming. Spain faces particular vulnerability to prolonged extreme heat, with potential for long-lasting high temperatures that could dwarf what was already a historically brutal 2022. Severe Weather Europe's latest analysis of midsummer atmospheric velocity, potential for July 2026, confirms a strong El Niño configuration already visible in the global atmospheric circulation, with the same Walker cell pattern that characterized the 1997 and 2015 events now clearly identifiable in model output. The first major atmospheric impacts are expected to be felt as early as the first half of meteorological summer. This is not a distant winter event. This is a summer 2026 story. Beyond the UK and Europe, the global consequences of what is forming are staggering in scope. South Asia faces severe multi-season droughts that can devastate staple crop yields. Southern Africa, which was hit hard during both the 1997 and 2015 Super El Niño events, faces similar drought conditions that could reduce regional maize production to a fraction of normal output. The Amazon rainforest, already degraded by decades of logging and previous El Niño-related drought, faces a new assault. Forest degradation driven by wildfires, logging, and drought already affects approximately 40% of the Amazon. A super El Niño against the backdrop of elevated baseline temperatures could increase the risk of widespread or unusually intense fires in normally damp regions, and peatlands and parts of Oceania can burn for months on end once ignited. East Africa, which has already experienced severe flooding in 2023 and 2024, faces increased rainfall risk in some zones, alongside drought in others, creating contradictory and simultaneous agricultural crises that overwhelm national response systems. The Middle East, already under extraordinary stress from geopolitical conflict and water scarcity, faces drought-related disputes that could emerge in Iraq, Syria, and Lebanon on top of everything else that is already destabilizing those societies. The United Nations World Food Program warned in early 2026 that the number of people facing acute hunger could jump by 45 million if existing crises persist. A super El Niño landing on top of that baseline does not add to that number, it multiplies it. Liz Stevens, a professor of climate risk and resilience at the University of Reading in the UK, told the BBC that more people are already living in poverty, and if crop yields fall because of drought or flooding from El Niño, that drives prices even higher. She described the potential for quite huge humanitarian impacts, especially if the crisis in the Middle East continues. That combination, a super El Niño, an existing Middle East conflict disrupting fertilizer supply chains, and a global food system already operating with razor-thin margins, is what experts are now calling a perfect storm. Some commodities are particularly exposed, with El Niño typically putting upward pressure on cocoa, food oils, rice, and sugar. Broader risks extend to bananas, tea, coffee, chocolate, and soy-fed meat. These are not niche products. These are the staples of daily life for billions of people. The energy implications are equally severe. Super. El Niño may intensify heat waves simultaneously, straining water supplies and power grid connectivity, prompting increased fossil fuel dependencies at exactly the moment when the world is trying to reduce them. Hydropower. Dependent countries face forced output reductions due to drought conditions. In India, a rise in electricity demand from El Niño conditions is expected to raise coal-fired power generation by 10% year over year. The feedback loop between energy stress and climate stress tightens with every degree of warming, and a super El Niño accelerates that tightening dramatically. A December 2025 study published in Nature Communications added a dimension to this picture that should genuinely disturb anyone paying attention. The researchers analyzed all three super El Niño events on record alongside climate model projections and found that events of this intensity significantly increased the likelihood of climate regime shifts. Abrupt, persistent transitions in temperature, sea surface conditions, and soil moisture that can endure for years or even decades after the El Niño itself has faded. The 2015 to 2016 Super El Niño, for example, pushed the Gulf of Mexico to a new sustained level of warmth that may have contributed to stronger hurricanes along the Gulf Coast in every subsequent year. Under global warming scenarios, the study found this effect would be greatly amplified. A Super El Niño does not just cause a bad year. It can permanently recalibrate a regional climate system into a new, hotter, more volatile state. The pace of development of this event is also drawing attention from scientists in a way that no previous El Niño has. ECMWF simulations suggest a particularly rapid development, possibly unprecedented, since the beginning of modern observations. One NOAA forecaster described the transition from La Niña to a developing El Niño as one of the most rapid that they have ever seen. That speed matters because it compresses the lead time available for adaptation, for agricultural planning, for government emergency preparedness, and for international humanitarian response. The systems that normally use months of early warning data to pre-position food aid, water resources, and emergency infrastructure are being given a short ER runway than they are built to handle. It is worth pausing to absorb what all of this means collectively. We are not talking about a bad summer. We are not talking about a few weeks of unusual heat. We are talking about a multi-year disruption to the global climate system, arriving at the worst possible moment in history in terms of background temperature, geopolitical stress, food system fragility, and institutional readiness. The 1997 to 1998 Super El Niño produced $32 to $96 billion in global economic losses, and it hit a world that was considerably cooler and considerably less stressed than the one we are living in now. A 2026 Super El Niño of greater intensity, developing on a background climate that is 1.2 degrees hotter, with supply chains already strained by conflict, With aquifers already depleted by decades of over-extraction, with food insecurity already at levels not seen since the early 2020s, the economic and humanitarian costs are not calculable from historical models. They represent genuinely uncharted territory. The question that everyone is now asking, and the question that institutions, governments, and ordinary people need to start answering, is not whether this is coming. The models have converged. The data is screaming. The probability is no longer a question of if. The question is what we do with the time we have left before it peaks. Kaveh Madani, professor and a director of the United Nations University Institute for Water, Environment and Health, has stated that viable solutions require a fundamental shift from reactive crisis management to proactive climate adaptation and disaster risk reduction. He specifically called out the concept of water bankruptcy, the idea that aquifers are being drawn down far faster than they can be replenished, as a hidden vulnerability that a super El Niño will violently expose. There's also a long-term statistical reality that the scientific literature is now documenting clearly. The occurrence of extreme El Niño and La Niña events has increased since the 1950s. Climate projections suggest the frequency of extreme ENSO events will increase further as global temperatures continue to rise. Recent research shows that El Niño events do not just cause short-term disruption, they can slow improvements in mortality for years, reduce life expectancy, and generate substantial long-term economic losses, even in high-income Pacific Rim countries. We are not managing a single event. We are managing a trend, and that trend is accelerating. The 2026 Super El Niño is not the worst thing that will ever happen. It may be the new normal of what powerful El Niño events look like in a world that has been pushed past the margins of safe operating space. For the people watching this in the United Kingdom, the message is not panic, but it is urgency. Above-average temperatures are already projected for the continent this summer. The jet stream is already shifting. The atmospheric fingerprints of a major ENSO event are already appearing in the models, months ahead of the peak. Whether this summer delivers a dramatic heat event for Britain, or whether the full UK impact is delayed into 2027, the surrounding world will be experiencing disruptions that will affect supply chains, food prices, energy costs, and the scale of humanitarian crises that demand international response. Britain does not exist in isolation from a planet that is overheating. No one does. The last time something like this struck the planet, in 1877, there was no satellite data, no global weather modeling, no international coordination system, and no scientific framework to understand what was happening until millions of people were already dead. We have all of those things now. We have the models, we have the data, we have the institutions, we have the lead time. The only question that remains is whether we have the will to use what we know before the window closes. Because what is building in the Pacific right now is not waiting for anyone to be ready. The heat is already in the water, the Kelvin wave is already moving, the clock has already started.